form, and if you have to find the addition of two vector, you can use this equation. Q1 plus Q2 is equal to addition of real part plus j into addition of imaginary parts. It will give you the addition of two vector. If you have to convert this vector, resultant vector, into polar form, then you can use this equation. Magnitude of this vector is this, and phase angle is equal to tan inverse imaginary part by real part. So magnitude and phase angle is known to you. So your resultant vector, you can represent it like this: magnitude angle phi. So this is your vector in a rectangular form, and if you have to convert it into polar form, so it will give you in a polar form also. So whenever addition is there, always prefer rectangular form because it is very easy. Just compare real part and imaginary part, so it will give you the resultant of given vectors. Now some of the examples of addition of complex number. As we have discussed the method of addition, same method you can apply for any vectors. Suppose in this particular example, two vectors are given, 2 plus j5. This is your first vector, and second vector is 4 minus j3. First of all, make the addition of real part. So real part is 2 and 4. So 2 plus 4. So here it is 6. Now addition of imaginary part. So 5 minus 3. So here it is plus j2. Same way, another two vectors are given, 175 minus j34 plus 80 minus j15. So it is 255 minus j49. Same way for third example, minus 36 plus j10 and 20 plus j82. Two vectors are given. Make the addition of real part. So minus 36 plus 20. So here it is minus 16, and 10 plus 82. So here it is plus j92. So using this method, you can make the addition of two vector, and if you have to convert it into polar form, you can easily convert into polar form using the given equation. Find the magnitude of resultant and then find the phase angle of resultant. So it will give you the vector in a polar form. Now we are discuss about subtraction of the complex quantity. Again, two vectors are given to you. Q1 is equal to A1 plus JB1 and Q2 is equal to A2 plus JB2. You have to find the subtraction of two vectors. So it is like this: Q1 minus Q2. As we are done in a addition, same way make the subtraction of real part. So here it is A1 minus A2 plus J subtraction of imaginary part. So here it is B1 minus B2. So Q1 minus Q2 is equal to A1 minus A2 subtraction of real part plus J B1 minus B2. So this will give you the resultant value in a rectangular form. Again, if you have to convert into polar form, to find the magnitude. So magnitude is equal to under root of A1 minus A2 square plus B1 minus B2 square. So square of real part plus square of imaginary part. So it will give you the magnitude. And phase angle, which is equal to tan inverse of imaginary part by real part. So here it is B1 minus B2 and here it is A1 minus A2. So phi is the phase angle of the resultant, which is equal to tan inverse of B1 minus B2 upon A1 minus A2. So your resultant will be like this: magnitude and angle is phi. So this is the resultant vector in a rectangular form and this is your resultant vector in a polar form. So in subtraction, always prefer rectangular form because it is very easy and you can easily convert into polar form also. Now we are discuss about some example of subtraction. Two vectors are given. One is 2 plus j5 and another is 4 minus j3. You have to find the subtraction of this two. So 2 minus 4 means subtraction of real part. So here it is minus 2 plus j8. It is the subtraction of imaginary part. 5 minus minus 3. So here it is 5 plus 3. So j8. Same way 175 minus j34 minus 80 minus j15. So your answer is 95 minus j19. Same way third example is minus 36 plus j10 minus 20 plus j82. So minus 36 minus 20. So here it is minus 56. And 10 minus 82, so here it is minus j72. So these are the example of subtraction. Always prefer rectangular form for subtraction. Now for multiplication and division, polar form is the favor notation to work. So always prefer polar form for multiplication and division because it is very easy in a polar form. Again we are having two vector q1 which is represented like this, a1 angle theta 1 means vector given in a polar form, and another vector q2 which is represented like this, a2 angle theta 2, and you have to make the multiplication of these two. So q1 into q2. So whenever you make the multiplication in a polar form, first of all multiplication of magnitudes are there. So here magnitude of first vector is a1 and magnitude of second vector is a2. So first of all multiplication of these two. So here it is a1 into a2 and then addition of the angle. So here it is theta 1 plus theta 2. So q1 into q2 is equal to multiplication of magnitudes. So it is a1 a2 and addition of the angle. So here it is theta 1 plus theta 2. So this will give you the value of resultant vector in a polar form. Suppose you have to convert this vector in a rectangular form, so you can convert using this equation. For rectangular form you have to find the real part and imaginary part of the vector. So first of all real part. So real part is equal to a1 a2 into cos of the given angle. Given angle is theta 1 plus theta 2. So this is your real part, and for imaginary part it is a1 a2 sine of angle theta 1 plus theta 2. Okay, so real part is known to you, imaginary part is known to you, so you can convert this vector in a rectangular form. So your resultant in rectangular form is real part plus j into imaginary part. So this is your resultant vector in a polar form and this is your resultant vector in a rectangular form. So whenever multiplication is there, always prefer polar form and then you can convert it into rectangular form if required. So whenever you make the addition and subtraction, rectangular form is preferable, but whenever you find the multiplication and division, always prefer polar form. Now these are the some of the example of multiplication. First, two vectors are given. First vector is 35 angle 65 and second vector is 10 angle minus 12. So as we are discussed earlier, multiplication of magnitude. So it is 35 into 10. So here it is 350 and addition of angle 65 minus 12. So your angle is 53 degrees. Same way another example is 124 angle 250. 11 angle 100. So multiplication of 124 into 11. So it is 1364 and addition of two vector 2 angle. So it is 250 plus 100. So your angle is 350, or you can write down in negative direction, it is minus 10. Third is 3 angle 30 and 5 angle minus 30. So 3 into 5 it is 15 and 30 minus 30 angle is 0. So these are the some of the example of multiplication. Now division. For division also you have to prefer polar form. Suppose one vector is given q1 which is equal to a1 theta 1 and q2 which is equal to a2 theta 2, and you have to find the division of this two vector q1 by q2. So for that you have to find the division of magnitudes. Here magnitude is a1 and a2, so a1 by a2, and then subtraction of angle. First vector is q1, so here first angle is theta 1. Second vector is q2, so minus theta 2. So this will give you the resultant value in a polar form. And as we had discussed earlier, same way you can convert this polar vector into rectangular vector. So whenever division is there, always prefer polar form. Make the division of two magnitudes and make the subtraction of given angle. So these are the example of divisions. First vector is given which is 35 angle 65, and second vector is given which is 10 angle minus 12. So first of all division of magnitude, so it is 35 divided by 10, so 3.5, and subtraction of angle, so 65 minus 12, so it is 65 plus 12, so angle is 77. Same way 124 angle 250, and second vector is 11 angle 100. So 124 divided by 11, so your answer is 11.273, and 250 minus 100, so your angle is 150. Third example is 3 angle 30 divided by 5 angle minus 30. So 3 divided by 5, so your answer is 0.6, and 30 minus 30, so here it is 60. So these are the example of addition, subtraction, multiplication and division. Now we are solve one example. Given V1 is equal to minus 10 plus J50 volt, and V2 is equal to 30 plus J20 volt. Find the resultant and express it in the polar form. So two vectors are given to you, or two voltages are given to you. First is V1 and second is V2. You have to find the resultant of these two. So as we had discussed earlier, for addition always prefer rectangular form. So for resultant voltage, V is equal to V1 plus V2. Equation of V1 in rectangular form is already given, and equation of V2 is also given. So addition of real part, so it is minus 10 plus 30 plus J, addition of imaginary part, so it is 50 plus 20. So your answer is 20 plus J 70. So this is the value of resultant voltage in a rectangular form. Now we have to convert into polar form. So conversion from rectangular to polar is known to you. First of all you have to find the magnitude. So magnitude is equal to under root of square of real part plus square of imaginary part. So our real part is 20 and imaginary part is 70. So magnitude is equal to under root of 20 square plus 70 square. So your answer is 72.8. Now we have to find the phase angle. So phase angle phi is equal to tan phi is equal to imaginary part divided by real part. So imaginary part is 70, real part is 20. So tan phi is equal to 70 by 20. So your phi is equal to 74.05. So your resultant voltage in a polar form is represented like this. V is equal to 72.8 and your angle is 74.05. Now resistance. Resistance is essentially friction against the motion of electrons. Resistance is mathematically symbolized by the letter R, and the unit of the resistance is ohm. Now reactance, as we know, reactance is essentially inertia against the motion of electrons, and it is present anywhere electric or magnetic field are developed in proportional to the applied voltage or current respectively. But most notably in capacitor and inductor, reactance is mathematically symbolized by the letter X and is measured in the unit of ohms. Now impedance. Impedance is the comprehensive expression of any and all the forms of opposition to the electron flow, including both resistance and reactance. It is present in all circuits and in all the components. Impedance is denoted by letter Z. Impedance of any circuit is denoted by this equation Z, which is equal to R plus Jx, is measured in the unit of ohms in a complex form. So R is the real part of impedance and X is the imaginary part of impedance. So R plus Jx is the rectangular representation of impedance. Now we are discuss about RL series circuit. We are assuming one circuit in which resistance and inductor are connected in series and alternating voltage is given to the particular circuit. So whenever this type of circuit is given and you have to find the total voltage or individual voltage across resistance and inductor, how you can find that we have to discuss in this particular session. So applying KVL, total voltage V is equal to VR plus VL. VR is the voltage across resistance and VL is the voltage across inductor. Now VR is equal to nothing but the current passing through the circuit. This is the series circuit. The current passing through the circuit is same. So VR is equal to I into R. And VL is equal to voltage across inductor. As we are discussed earlier, whenever you are consider about inductor, reactance is present over there and which is oppose the flow of current. So VL is equal to I into XL and XL is the inductive reactance. Thus V is equal to I into R plus XL. I is constant because this is the series circuit. Also V is equal to, magnitude of V is equal to under root of VR square plus VL square. This is the algebraic sum. So magnitude of V is equal to under root of VR square plus VL square. And phase angle phi is equal to tan inverse of VL by Vs. This is the phasor diagram for a RL series circuit as shown in figure. Voltage across R is VR and voltage across L is VL. Now as shown in figure, this is your VR, means voltage across resistance. In